Alright, let's take a quick look at our problem set. So for question 1, the procedure we were following, nice and straightforward. We just go through this stuff. We don't even have to do any real setup. We might simplify or expand or whatever does the trick for us to make things a little bit easier. But there's not a whole lot of setup, and there's no real interpretation either. We're just solving an equation. We are finding where does the slope turn to 0, and there might be more than one place that's the case. We might have multiple critical points, which means we would have multiple places to check the second order condition. But it all boils down to asking for some function, where does it hit 0? Where does it flatten out? Where does the slope, hit 0? Where the slope hits 0, then we then ask, is that point a point where the slope is 0 and gets bigger, right? Or is it a point where the slope gets smaller? Now I'm telling this second order condition as we move to the right, as we increase the value of x, but we can use the same interpretation to understand that we're getting smaller to this point. Right, so here, this f prime, this is showing us that for this orange function, we start with a negative slope, right, and our positive second order condition is telling us that where we're at 0, we are increasing. We're increasing the slope. And so to get to 0, we must have started from somewhere less than 0. So if we started from less than 0, that means the slope function started negative. So we have a negative slope, we hit 0, then our slope is getting bigger into the positive range. Again, that is why that second order condition is telling us that we're looking at a minimum. For f double prime less than 0, that means we're hitting a point where the slope is 0, and as we go further, that slope gets smaller. We go from 0 to something negative. All right, but let's take a look at questions 2 and 3, because here we've got the trickier parts, the setup and the interpretation. Now, the classic thing you're going to have to do with setup is to try and think about what is the thing that actually matters. So for question 2, we can see right here, I've got a big hint here. The goal is to maximize profits, which according to blah, 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 right? So here I'm just giving you an idea of how to answer this. This isn't really the answer, but it does give away what your objective is, right? So here we've got it set up immediately. We don't even have to worry about the setup for this particular part, question 2a. So we can jump right into that. So we always use pi to represent profit. Whatever. Try again. Pi. So pi, this is profit. And profit, this is just total revenue minus total cost. Nice and simple. In the case of 2a, that's already set up for us, so we can just jump right into it. Now, I'm not going to jump specifically into it because I want to see you guys do it, but I'm going to make up just a slightly different version. So we've got, let's say, negative 3 times q to the 4 plus 200 q squared minus 30q plus 20, right? Totally made up off the top of my head. Probably doesn't really correspond with anything, but who cares, right? The point is just the example. So we start with our objective, and then we just go through the procedure, which is we find our first order condition, right? So we ask, where do we get pi prime equal to 0? And to get that, we just use our power function rule for each chunk of this polynomial. So we're going to get what? Minus 12 times q cubed plus 400 times q minus 30 plus 0. I'm not even going to write out plus 0. And then we solve for q. Now, I'm not going to solve a cubic, but I might ask Wolfram to say, solve this equation. 0 equals all this stuff. I'm not asking you guys to do that. I'm only asking you guys to solve the function, the first derivative of a quadratic function. So your job's going to be a lot easier. So we set that up, we solve for q, we get some q star, then we check our second derivative, right? So Q star equals whatever. We'll put in just a placeholder question mark. And then pi double prime in this case is going to be minus 36q squared. Right, we bring that 3 down. 12 times 3 is 36. We keep our minus sign. It's easy to lose those, so be careful. Here, let me go to full screen. This will be a little bit easier for you to see. There we go. 3 times negative 12 is negative 36. 3 minus 1 is 2, so minus 36q squared plus 400. Right, nice simple derivative rules, and then that goes to 0. So now what we have to figure out is whatever it is our value of q star is, and in this case we're going to have multiple, right? But whatever values we put in, we want to ask, is this bigger than or less than 0? So it's going to depend on the value of q. So 36q squared, if this figure, right, notice we got our minus sign here. So 36q squared, whatever that is, if this is greater than 400, then we're saying minus 500 plus 400, well, then that's going to be less than 0 for pi double prime. Right, our second derivative less than 0. Again, what does that mean? Well, we've got some function. We're looking at some point where it is 0, and it is getting smaller as we go past that, the slope, pi prime. So here we've got a slope of 0, and it gets smaller. It goes to a negative slope. Right? It started at a positive slope. It got smaller until it was 0, and then it kept getting smaller past 0. So at this critical point, right, this is one of our possible q stars. This would be a case where pi double prime is less than 0. Right? So where we're looking at a local maximum, the peak of a hill instead of the bottom of a valley. All right, so for those, right, you're looking at something that's pretty straightforward. Again, heavy hint here. When we're talking about a firm, we're usually thinking about a firm interested in maximizing profit. Now, there are different situations where we want different assumptions. So we might think the firm overall wants higher profit, the owners of the firm want higher profit, but maybe a particular manager is more concerned with something like increasing their revenue. Right? If you are compensated based on the revenue you bring in, but you don't face any sort of a salary penalty for increasing costs, you might really want to drive up costs to increase your revenue without really caring that you're increasing costs faster than you're increasing revenue. And this was sort of an old problem in the movie business. My understanding is this has changed somewhat, but it used to be the case that the people involved in underwriting a movie cared more about ticket sales than about the underlying profit. Now, obviously, that's not terribly sustainable in the long run. So a smart movie studio is going to be really concerned with finding ways to deal with that total cost issue. They might do that through particular rules about what sorts of projects get the green light, or they might try to more directly tie in some incentives. So we might, for example, imagine that Tom Hanks is getting ready to start making a movie. Say Amazon is going to underwrite it, and they want to figure out a way to align his incentives with everyone else's, right? So you don't want to just say, we're going to give you a percentage of the gross profits. We want to see that you get a percentage of the, sorry, not the gross profit, the gross revenue. We want to see that you get a percentage of the overall profit, right? That means that you're also facing some portion of the total costs. But let's imagine something a little bit weirder. Get a fresh page here. So, what are we looking at? Hollywood actors and producers are sometimes paid as a percentage of gross sales. You are working for Tom Hanks as his agent. You want to get him paid as much as possible. And you have some sort of a contract where some part of his pay is based on revenue, right? So Tom Hanks payment, right? Does he get $100 million? Does he get what, right? How much money does he get? This is a function of the profits, but it's also a function of the total revenue. Now we can rewrite this a little bit because we know that profits are the total revenue and the total cost. So let's go ahead and lay out this part. I'm going to try not to give too much away because I want you to exercise your setup and interpretation muscles on this problem. Don't worry too much about getting it perfect. Worry more about actually making an honest attempt. So you have some model of demand for the movie. You know that some percentage of his income is based on gross revenue and some is based on the profit. So we'll use these terms from the question, alpha and 1 minus alpha. So the part of his payment that's coming from profit, let's just say, is alpha times profit plus 1 minus alpha times total revenue. And then let's use our definition of profit to make this a little bit easier to see. Profit is total revenue minus total cost plus 1 minus alpha times total revenue. Total revenue, let's bring in a little bit of good old-fashioned supply and demand. We've got some demand curve, and that demand curve is going to tell you what price quantity combinations are possible. So we find some price, right? We're ultimately looking for P star for Tom Hanks that is going to maximize this underlying function, but let's just focus on the total revenue aspect for now. Right? Let's ignore the costs. We find the price where it's not so high that we lose a lot of volume, and it's not so low that we sell a lot but don't make any money off it. It's somewhere in the middle. Right? This is like the problem of maximizing profits for a monopoly that has zero marginal costs. Right, so this is the underlying problem that we're trying to do. Let's take a step further with this setup. So total revenue, this is going to be price times quantity, but our underlying total revenue function, we have it set up as Q, not even set up, we just have it introduced in the problem as Q is some function of price. And our total revenue is going to be quantity times price. We just multiply price on both sides of this equation. And now we've got total revenue, is price times quantity, is whatever this function is times the price. So I'm going to be very general here. I'm not going to put in a specific function, although you might find your life is a little bit easier if you just make something up. I would pull something from the Schoen's Guide to Mathematical Econ. There's a lot of good, nice, worked out examples there, so you can't go too far astray. But let's keep working on breaking this one down. So here we've got alpha times total revenue minus alpha times total cost. So I'm just breaking this up, plus 1 times total revenue minus alpha times total revenue. So hey, alpha times total revenue minus alpha times total revenue, this is nice. So really, we're looking at total revenue minus alpha times total cost. So whatever alpha is, maybe it's 0.5, he gets half from profits, half from revenues. Right? And I guess actually there really should be another thing. I didn't quite give you enough information in the problem set as it's currently written, so here's your incentive for watching this video. We should have, let's say, we'll call it just B and C in here, right? So he doesn't get all the profits. He gets some percentage of his total compensation and some proportion of the profits, right? So maybe B is something like 0.05. He gets 5% of the profits, which might be the case for a big name actor like Tom Hanks, probably not going to be the case for a nobody. And then C is going to be some portion of total revenue. And maybe the executive producers want to make sure that he has incentive not to make a whole bunch of ridiculous requests, right? So maybe he's directing too, and he has some ability to add costs. So in that case, he might say, let's throw in a whole bunch of explosions because people will pay more to see more explosions. That'll bring me more total revenue, even if it lowers my total cost. Right? So we want to make sure that we don't have C be too dramatic compared to B. Or really, we want to make sure that alpha times B and 1 minus alpha times C probably pushes him more in this direction to being concerned with profits than total revenue. But the point of this exercise is not to come up with a good contract, it's to see how we can frame the issue. Right, so maybe C is, maybe he gets 1% of total revenue, right? Something along those lines. Now there are a lot of ways that we could modify this. This is really just a starting point. Start from here, try stuff, and the big thing to do here is to ask yourself, does this make sense? And to convince yourself that either it does make sense or to try and figure out where things go wrong. Now, I know that you guys want me to give you more than that, but I think that this gives you plenty to start with, right? This is sort of giving us some element of the setup. Let me just, so I don't go nuts, add in our C and our B to all these various places. I'm just going to scratch that out. But we're going to have something like this. We're going to shake out what that equation is. And then given whatever that equation is, which is going to rely on total revenue and total cost, we're going to come to some way to come up with a price. Now, personally, I feel more comfortable avoiding specific numbers. Right? I've been doing these problems a long time, and what I find is when I throw in specific numbers, I get confused. I introduce chances for errors. Using the abstract symbols feels weird. It's not the place that we normally feel best. But when we start with this generic thing, we're ultimately going to boil this all down to something like our ideal price as far as Tom Hanks is concerned is equal to some function of all these different parameters. Right, so it might turn out to be something like, well, let's see. So we're going to be doing our basic procedure. So let's just use this version, total revenue minus alpha times total cost. So in that case, we want to find where does this whole derivative equal 0. So this whole thing, dp, right, we're going to use price as our choice variable. We're going to solve for 0 here, and we're going to end up with some price along the lines of, I don't know, maybe it's going to be like, you know, total revenue prime minus alpha total cost prime, right, whatever, right, bunch of other symbols. So give it a shot. I'm not going to try and do this off the top of my head right now because this is already an 18-minute video. It doesn't need to be a 40-minute video. But give it a shot, and as usual, ask questions in the usual places, and I will talk to you in the future.